Hello everyone, and welcome to the basic architecture and security presentation for Spin. First, for those of you not familiar with our product, a quick overview. Spin is an AI-powered collaborative notebook platform inspired by Jupyter Notebooks, but purpose-built for operational workflows with enterprise-grade security and collaboration features in mind. So you can operate across multiple tools and services across all your environments seamlessly. And Spin can replace your outdated tutorials and runbooks and accelerate your journey to full automation with the power of AI. In this presentation, we will shed some light on Spin's architecture and the security and sharing features of Spin. If you would like more information or would like to try it out, please visit www.siftd.ai/spin. Let's dive into the Spin's design. Spin consists of three main components that work together seamlessly. First, we have the Spin UI. This is the web interface where users and administrators manage and run their notebooks. Next, on the left-hand side here, you see the Spin server. This is our cloud service managed by us, Siftd. The Spin server manages the metadata and compiles notebooks for the Spin runtime agent to execute. On the right side, you'll see the Spin runtime agent, or just runtime for short. And this is the execution environment where your notebooks run the code. This can be deployed either in your own infrastructure or hosted in the cloud, giving you complete flexibility where your code executes. Security was top of mind when we engineered this platform. The Spin server component, hosted by us, adheres to the principles of zero data access. It never sees your actual data. All notebook execution happens exclusively on your Spin runtime agent. This means your sensitive data never leaves your infrastructure. We've architected this specifically so that even we, as a service provider, cannot access your proprietary information. As part of this design, Spin maintains an isolated network architecture. The Spin server never initiates requests to the runtime agents. All interactions are mediated by the user through the Spin UI. This creates a natural air gap and prevents any unauthorized access paths. All network traffic is sent over HTTPS. Each runtime agent is additionally secured with a unique Spin token. This prevents unauthorized runtimes from accessing your data. Additionally, the server encrypts all data payloads using the Spin token before transmission, adding another layer of protection. We understand the policies for secret management may vary based on your compliance needs. As a result, we provide a couple of options for secret management. You can store secrets directly on your infrastructure where the Spin server has no access. We call these Spin runtime secrets, or just runtime secrets. This option ensures your secrets never leave your infrastructure and are fully managed by you. Alternatively, we also offer cloud secrets through our secure GCP secret manager integration. You are free to choose which method works best for you and your security requirements. Spin also has an RBAC model that's optimized for secure sharing and delegation. This is where Spin really shines for enterprise teams. Picture this common scenario. You have an expert user, say a database administrator or a cloud architect, for instance. Suppose the expert needs to share operational capabilities with less privileged team members. Traditionally, this means either sharing credentials or creating new ones for the less privileged user, which is risky and cumbersome to manage. Or you fall back on having the expert perform every task, which bottlenecks the organization and doesn't scale. Spin solves this with our run-only sharing model. A notebook author who is a high privileged user can safely add credentials that are shared across the entire workspace. The sharing is safe because secrets are completely inaccessible to the run-only mode user. The actual passwords, API keys, or service account credentials are completely hidden. The notebooks act as a guardrail because the run-only user can only execute what's specifically defined in the notebook and nothing else. They can't do anything outside of what is defined, like deleting stuff in your database or exploring the cloud infrastructure internals or invoking random API calls or things that you generally don't want the less privileged users to meddle with. They get exactly the operational capabilities the expert encodes for them within the notebook, with natural boundaries that prevent credential abuse. Think of a notebook as being analogous to a self-service application that uses a service account behind the scenes to access internal systems, but only exposes a small subset of functionality to the end user. Finally, the sharing is robust because the notebooks are authored and run in the same execution environment, the Spin runtime, and it uses the same credentials set as we have described above. This means all of the various actions in the notebooks are highly repeatable and predictable. When the expert tests the notebook, it runs in the same environment as when the team member uses it, using the same credentials. No more of the pesky problems of, hey, it works on my machine, but why not yours? The result is that your expert can safely scale their capabilities across the team and even outside their team without compromising security or reliability. We hope this sheds some light on how Spin can help you and your team collaborate more effectively. If you'd like to learn more or want to give it a try, please visit our website, www.siftd.ai/spin, or contact us at info@siftd.ai. Thank you and have a great day.